Hi everyone, my name is Stuart Lynch, and welcome to the start of a new series where I'm going to show you how you can create your own Swift package where you can include a picker for your users that will allow them to select from one or more categories of SF symbols so that they can change an image that might represent something in your project. Our end goal in this series is to create a Swift package that we can use Swift Package Manager to install into any of our projects. The SF Symbol Picker package will have a few options. You'll be able to present all categories of symbols to your users to allow them to pick one from a modal sheet presentation. Or you may wish to limit the choice to a single category and maybe present it as a popover. And it's not all or none. You can also provide an array of categories that you may wish to limit the choices to. Or you can even specify your own search term, like I'm doing here, to only display sports symbols across all categories. All of the other options will have a search text field in there. That will be your choice in your app. But first, we're diving into something that comes up a lot in iOS and macOS development, and that's property lists, or plists for short. A property list is a structured way to store simple data like strings, numbers, arrays, and dictionaries. Think of it as a lightweight, human-readable file format that's perfect for things like app settings or configurations files, or static data that you want to bundle with your app. So in this video, I'm going to show you how you can decode plists into Swift models. And these plists will contain all of the information that you'll need to create an array of symbols to present in your pickers. So if you've ever opened a plist and wondered how to actually use it in your code, well, you're in the right place. There is a starter project for the video, and I highly recommend that you work along with me on this one because the completed source code will be used in subsequent videos in this series. And you can find the starter project at the link in the description. There is a completed source code branch as well that contains the completed code for this video, but if you're working along, make sure you download the zip file containing the starter project. So let's start by creating our own first property list to get an idea of how we can decode it. Now, before we find where to get plists containing the SF symbols information, let's go back to the basics and create a simple plist. And I'll show you how to create a model representing the data contained in the plist and use a PropertyListDecoder to decode the plist. Well, in the starter project, you can go to the Intro tab and expand it to reveal the sources and resources folders for the playground. Well, I want to create a plist in the resources folder for this page, but unfortunately you can't create new files other than playground pages within a playground, or at least I couldn't figure out how to do that. And this is rather unfortunate, but we can, if we have them already created, drag them in here. So I'm going to temporarily create a new Xcode project. I'll just use Command-Shift-N, and I'm just going to create a new project for any platform. And I can call it whatever I want and save it wherever I want because I'm going to trash it in just a minute anyway. Well, once the project is opened, I can create a new file and I'll search for a property list. I'm going to select it and I'm going to give it a name, person, as this is going to represent a person. The root of a property list can either be a dictionary or an array. And you'll see both in today's tutorial, but let's start with it staying as a dictionary, and then a dictionary contains key value pairs. When we're creating models, if you have a dictionary, the keys can represent the values of your model's properties, while the values of those property. So let's add a row and enter name. And since the name is going to map to a property that we want, we'll use lowercase. And for the value, it's a string by default, so you can just enter your name. Click on the plus button to add another row to the root. And for this key, we're going to specify age, and we're going to make it a number. We can't choose integer or double, it's just number. And then we'll enter your age. Now you know how old I am. I'll add another key, and I'll enter is alive, but I'll choose Boolean this time for the value. And you can choose yes or no, and this will map to true or false. So I'm going to choose yes, obviously. And then I'm going to add another row and call it siblings, but choose as the type an array. Now we can add to the siblings row itself. So I'm going to add a new row, and this will indent and create a new dictionary for item 0 with a type of string by default. Well, that's good. I want it as a string, and I'm going to enter the name of one of my siblings. And then you can repeat for all of your siblings or make up your own if you need to. I have 2, so I have 2 rows. Well, you can go into multiple rows deep, and we can see more examples of that. But for the time being, our plist is complete. And since the root is a dictionary, when we decode it, we'll be able to map each of the keys to a property in a model. Now, the property list is actually an XML file. And if you right-click on it and choose Open as Source Code, you'll see that. But let's switch back to the property list and open it as a property list, as it's easier to deal with. So I'm going to right-click on the person.plist to reveal it in the Finder. And now I can drag it into the resources folder for the Intro Playground tab. And I'm going to make sure that I specify that the action is to copy the file to the destination. So we no longer need that test project now. You can get rid of it. So now we can return to the Intro Playground. And at the same time, I'm going to hold down the Option key on my keyboard and tap on the plist to reveal it in a separate pane to the right. Inside the playground, then I'm going to create a new struct called person, and I'm going to conform it to the decodable protocol. And then I'm going to create a property for each of the key value pairs in our property list. And the order doesn't have to match up. So I'm going to start with name as a string, age is a number, but we can specify that it is an int, is alive is a bool, and siblings will be an array of string. So now I need a function that's going to decode our playlist into our model. So for this, I'm going to create a new function that's called Decode plist, and it's going to return a person. Well, this function will be exactly the same as if we were decoding a JSON file into a person object, with one exception. Instead of using a JSON decoder, instead we're going to use a property list decoder. Everything else will be the same. And the plist is in the bundle for this playground, so to get the URL, we can use a guard check and use the bundle.main.url function for the resource by specifying the name of the file and the extension. So the name of our resource is person, and the extension is plist. And then if it fails, we can simply present a fatal error, like failed to locate file. Similarly, we can use a guard check to extract the data by using the optional try to create a data object from the contents of the URL. Again, if it fails, we'll produce a fatal error. Now, as I mentioned, this isn't a JSON file, so instead of using a JSON decoder, it's a plist. So we're going to create a decoder that is an instance of a property list decoder. And then we can do a final guard check to use an optional try to use the decoder's decode function to decode a person object, so .self, from the data, and that gets assigned to the decoded data property. And again, if it fails, we'll produce a fatal error with a string. And then we can return the decoded data. Now I can test this in the playground right now by creating a person object and assigning to it the results of calling the decode plist function. And then I can print the person's name, the person's age, and the person's is alive status in a single print statement on a single line, so separating by columns. And then since siblings is an array of strings, we can execute a for each method on this property to extract a symlinks iterator, and we'll print that to the console too. If we run this in the playground, it'll decode the data, assign it to person, and when we do our print statements, we see it printed to the console. Now this function is going to come in handy for the rest of our playground pages, but the type and plist file name will be different. So why not create a generic function that we can use and then store it in a location that will be available to all playgrounds? And that location is the sources folder for the entire playground. So let's just leave this function here for now for reference, but I'm going to copy it to the clipboard. Now I can select the sources folder for the playground itself, the main playground, and paste it from our clipboard to create a new file. And I can give that file a name, and I'm going to call it PropertyListDecoder. Now I'm going to need to import Foundation. But because this is outside of our initial playground, it has no idea what a person is because each playground is a separate module. So this file can't see person. And in fact, the playground can't even see this function. To fix the first issue, instead of returning a person, I'm going to use generics, but I'm going to specify that the function will utilize some type that has to be decodable and that it will return that type. And then in the guard statement, we'll need to decode t.self instead of person.self. And we fix the second issue by adding a public designation to the function so that it can be seen from another module. If we return to our intro playlist now and run the playground, we'll still see it referencing the local version of the function. If we comment out the function, however, in the playground, it will use our global function. However, it doesn't know what the type is, so we can fix that by making sure that our person property is in fact designated as a person object. And when we run the playground, it works. But in the future, our decode plist function will be decoding from a different plist file. So I'm going to return to the function and add another property that I can pass in from the caller. And I'll preface my label file name with from. And then I can replace the hard-coded person string with file name. And then I can replace the hard-coded string file string in each of the fatal errors with that variable using string interpolation. Back in the info playground, I'll need to pass in the plist name without the extension. Now I want to make one more change. I don't want to specify the type when I create the variable. I'd rather pass that into the function itself. So I'm going to return to the function, and before the file name, I'm going to add an unnamed parameter, so we'll use an underscore, for type, that is a t.type. Now we can return to the call site, and if I create this right from scratch now, we see we're asked to provide the type, which is person.self, from the file that is being decoded without the extension, which is person. Now this will also allow us to decode not just a person, but perhaps an array of person, or any other object for that matter, so long as that object is decodable. I hope you're enjoying this video, and if you are, please give it a thumbs up and leave me a comment. It would also really help if you could subscribe to my channel and enable notifications so that you're alerted when I drop a new one here on YouTube. I put out weekly videos and I seldom miss a week, so if you really want to support my work, you can buy me a coffee. A link is in the description. Well, now that we understand how to decode property lists and we have a generic decode function, let's find out where we can find the property lists that will allow us to build an SFSymbol picker. And there are a couple of ways to locate the SFSymbol property lists. Let me show you the first where you might be able to find them on your system. If you go to the Finder and then type Command-Shift-G or choose Go to Folder from the Go menu, you can enter System /library/private frameworks to locate the private frameworks on your Mac. Then you can just start typing SF symbols to jump right down to the SF symbols framework. Well, you can open that, go to Versions, then A, then Resources, then locate the Core Glyphs bundle, and then right-click on it to show the package contents. And then open the Contents folder, then the Resources folder, and here you'll find, along with some other files, the plist that we'll want to use. Well, there is a way to access this in code, but I had some severe latency issues with this, and I am reluctant to access a private framework in my code. But we could simply copy these plists into my project bundle. And in fact, we will be doing something like that. But there's one plist that for me just hasn't have enough information in it, and that's the categories plist. If I open it up, you can see that it is an array of dictionaries, with the key being a category, an icon, and an SF symbol string that represents an image of that category. And if you open item 9, you can see that the key is not really a string that we would like to use to represent the category. So remember that there are only two properties here because I'm going to do something different. Let me show you how I also discovered, and which we will be using in our project, that the SF symbol plists are part of the Apple's SF Symbols app. So if you haven't already, download the latest SF Symbols app from the Apple developer site. I'll leave a link in the description. At the time of this video, that is version 6. So you can use the DMG to store the application somewhere like your applications directory, and then locate it, and then right-click on it to show package contents right here. Then all you have to do is navigate to the Content, Resources, and locate the metadata folder. And here you'll find those same plists. Now, if you open the categories.plist here, you'll see that there are 3 key value pairs for each category. There is an additional label key. And if you expand item 9 here, you'll see that the label is a much more friendly string that we can use in our project instead of just the key value that was available in the other locations categories plist. For this project then, I'm only going to use 4 of these plists. So make sure that your playground is open and the sidebar is displayed. I want a single location where I'll be able to access those plists from any one of my playground pages. And that is the one that is the full resources folder at the end. So I'm going to hold the Command key down and select all of the plist files except for the layer set availability plist. And then hold down the Option key and drag them into the resources folder to make copies, and make sure that you choose Copy Files to Destination. Now that we have our plists in place, we can now set up a model and decode into a test for each of these 4 plists. So open the Categories Playground, and then hold the Option key down and click on the Categories plist to have both panes available to use side by side. And we can see that this plist is an array, not a dictionary like our person case was. But each array item is the same with 3 key value pairs. So if we want to decode this, then we'll be decoding an array of those key value pairs. And we can map to a struct of our own creation. So I'm going to create a struct called category that conforms to the decodable protocol. Then I can create 3 properties representing the keys for each of our key value pairs. So icon as string, key as a string, and label as a string. Next then we can use our decoder function to decode our plist into an array of category that we can call categories. So we'll let categories equal the decode plist, where the type is an array of category .self from the plist that has the name categories without the extension. Now if I print categories.count after this, I can run the playground and I can see that there are 31 categories printed to the console. And if I wanted to loop through each category and print the label, we could use a for each loop on the array. So categories for each, which is going to give us a single category in which we can print the category.label. Perfect. Let's move on to the next playground page for symbol categories. So we'll select that page, and then again, we'll hold the Option key down and click on the symbol underscore categories plist to get it on the right-hand side. This is a dictionary now, but our keys are strings representing one of the symbols, and the values are an array of strings representing one or more categories that the symbol belongs to. For example, if you expand circle.fill, you'll see that it belongs to the indices and multicolor categories. So I'm going to create a new struct called symbol underscore categories that is going to conform to the decodable protocol. And we're going to specify that the key get mapped to a name property, and the values will map to a categories property that is an array of string. Well, this will give us an array of symbols that have categories and an array of categories that they belong to. So if we use our decoder to decode, we'll have to do this first. We'll need to first create a property called symbol categories dict, where we can use our decode plist function. We can't decode directly into our symbol underscore categories struct. Instead, we need to decode into the type that is a dictionary of type string for the key and an array of string being the value.self. And the plist name is symbol underscore categories. So now to build our array of symbol categories struct, we'll use a dictionaries map function. Once we have our dict, we can use the map function that's going to give us a key and a value. Well, the key is the symbol name, and the value is the array of string that we can call categories. So instead of key value, we'll simply use name categories. And then we can return a new instance of the symbol category struct using that key of name and value of categories to map to the symbol categories properties. If you print out the count of this array, you'll discover how many symbols have categories. And you can see that there are 6,824 in this version of SFSymbols. Well, we can also pick one of them, like the one at index 10, and find its name. And we can find that one's categories as well. And we can print those out. And for me, that's the briefcase.circle.fill, and it belongs to the multicolor and objects and tools categories. But there's no guarantee that that's what you'll see, because when you decode, you can't be guaranteed of the order. Symbol plus search is almost identical to our symbol plus categories. So I'm going to open that page and its corresponding plist on the right. And we can see that it too is a dictionary where the key is a symbol and the value is another array, this time of search terms, that apply to that symbol. So we can decode this very similarly to the one that we just did. So I'm going to create a new struct called symbol underscore search terms, conforms to the decodable protocol, and create two properties. Name as a string, and search terms as an array of string. And then again, I can't decode directly into this struct, so I'm going to have to create a search terms dict. And then I can use the decode plist function, where the type is this dictionary, which is key of string, and the value is an array of string, so .self, from the symbol search plist. So once we have that, it's been decoded, we can then map into that search terms array. So the search terms array is going to be the search terms dict, where we'll map the key and value, but the key is the name and the value is search terms. And we can create an instance of that symbol underscore search terms. And if we print out the number of symbols here, we can see that there are 2,818 of them that have search terms associated with them. The final plist to decode is the name underscore availability plist. So we can open again both of those related files side by side as usual. Now this looks very similar to the person plist that we created at the beginning of this video, where there are two key value pairs. So we should be able to decode directly into a model struct. But the values are not core types like a string or a number. They are both dictionaries. And if we expand the symbols key, you can see that its value is a dictionary where the key itself is a symbol and the value is a year dot version. We can specify the type then as a dictionary of string. And then if I expand the year to release, we'll see that the key is a string representing the year dot version, but the value is another dictionary. And that dictionary has a key that is a string representing an OS platform, and the value is a string that represents that platform's release version. So this means that our year to release type is a dictionary with a string key, but a dictionary for the value as well that is a string key, but another dictionary with string keys and values. So I'm going to create a new struct called symbol availability that this time will conform to the decodable protocol, and I'm going to create two properties with the same names as the keys. The symbol property type then is going to be a dictionary with a key and a value both being strings. The year to release property though is another dictionary, but the key is a string, but the value is another dictionary with string, key, and values. Since the types for these properties in our symbol availability struct match the format of our plist, then we can decode directly into this property list. And we're going to call that the symbol availability. Use the decode plist where the type is a symbol availability type.self from the name availability plist. And then that symbols dictionary then contains all of the symbols, including those that do not have any category or search terms associated with them. And then if you print out the symbol availability's keys.count, you can see the difference. We found that there were only 6,824 symbols that had categories, but we can see that there are 8,181 symbols in total. So what this means then is that when we go to build out our full symbol model, that our base will be this plist, so that we can ensure that we have accounted for all symbols. Well, now that we've verified that we can decode each of those plists, we can use that information to build a symbol struct that will be composed of all of the information that we have decoded. So first, since we created all of our model structs in each individual playground, they won't be available to the full fifth one here, the full symbol playground. So we'll need to return to each of our playgrounds and copy and paste just the models for each of those models into the top of this playground so that our playground can find them. So we'll do that for the category, for symbol categories, for symbol search terms, and for symbol availability. Now I am going to want to create one more struct, and that's called OS versions. It doesn't have to conform to the codable protocol because we're not decoding from a plist, but we want to get an array of OSs and versions for each symbol, and both of those then are going to be strings. Now I'm going to create a symbol struct. And this will have a name as a string, a release year as a string, a category that's going to be an array of our categories, a search term, which will be an array of string, and OS versions, which will be an array of our new OS version struct. So let's create a function that we will use to build our symbols. So I'm going to call that function build symbols array, and it's going to return an array of symbol. So in the body, let's first create an empty array of symbol, and then I'm going to return that variable to stop the function from complaining. And our code then is going to fit in between there. So let's get going and decode all of our components by decoding each of the plists one at a time. So each one is going to either get decoded into categories using the decoder into a category array of .self from categories. We'll use the symbol categories dict to decode the plist of the string array of string .self type from symbol categories. A similar one for the symbol search dict. And then that final one, the symbol availability. All of those are direct decodes into those properties. Now remember, I said that our base has to be that symbol availability's symbols property, as it has those 8,000 plus symbols. We don't want to lose any. And this is that dictionary where the symbol name is the key and the release year is the value. So we can use those labels as our keys and values in a for loop. So that's going to give us the first two properties of our symbol. To get the categories for the array, we can find the symbol categories from the symbol categories dict, where the key is our name property. So we're getting the categories for a specific symbol. Now this is going to be optional, so we can nil coalesce this into an empty array in case the symbol doesn't have any categories, and we know that that's true. Now these are just strings though, so we'll get the actual category structs for the symbol by using a compact map in case of duplicates on this array to extract the name, in which the first one is where the key for the dictionary is equal to the name. So now that gives us our third property for the symbol. To find the search terms, we'll do a similar but simpler process, where the search terms are going to be equal to the symbol search dict's dictionary, where the key is the name, and we'll nil coalesce that into an empty array. Again, not every symbol has search terms. To get the OS versions, we can start by accessing the symbol availability's year to release value for the key. That's the release year that we're actually looping through in this for loop. And this is a dictionary itself. So we can call this the OS availability dict. And since this is optional, we'll need to nil coalesce it to, this time, an empty dictionary so that it is not optional. Now remember, this dictionary then has the OS and the OS version. So we can simply map those then to a new OS versions object using the OS and the version, the key, and the values. Well, we have all of those properties now with that for loop. So before we get out of the loop, we'll create a brand new symbol object and append it to our initial empty array. So that's it. Outside of the function, we can call the function to get an array of symbols. Now you're going to find that this actually takes quite some time in the playground because it's displaying the results step by step. And on my system, it actually takes about 15 minutes. So I'm going to speed up this video. The good news though is that when we put this into our app, it's going to be quick. But in the end, when it finishes, you'll see that you have 8,181 symbols in the array. That's exactly what I want. And if you tap on the little box to the left of the final statement, which is the symbols array, you can inspect every one of those elements. And you can expand any one of them to see each of the properties. And in the case of the categories, you can even expand that to see each category's element in the array. We have what we need now to start building out our picker in a new Xcode project. If you found this tutorial helpful, please give it a thumbs up and leave me a comment. You can subscribe to my channel to get notifications of new videos. And remember that you can also download my YouTube channel listing app for free and quick access to all of my 350 plus YouTube videos. A link's in the description. And also remember I have a full SwiftUI course available on my Teachable site where you learn how to build a fun multi-targeted app.